Hello everyone, in this video we are going to see about performance metrics and measures of a parallel computer. If you want to measure the performance of a one parallel computer, first thing we need to focus on the design of the hardware and software systems used in that parallel computer, because the performance metric is purely based on both hardware design and software design. It is not only depend on the only on hardware, it is not only depend only on hardware. So it is basically purely based on both hardware design and software algorithms, software structure and software, what are the software platform you are using in a parallel computer. So in both the performance only, both its value only, you are going to find the performance metrics. How we can measure the performance of one parallel computer means, before that they were using some terms and measurements. What are those means? MIPS, million instruction per second, and million floating point operations per second. So what, likewise they were using some of the measurement unit in previously. Now additionally we are now going to see about more performance metrics in this video. So what are those means? Parallelism profiles and degree of parallelism and asymptotic speed of factors and system efficiency, utilization and quality standard performance measures. So these are the some of the important new terms and metrics which we are involved in the performance of your parallel computer. We know that what is meant by parallelism. Parallelism is one of the technology where n number of processors are executing parallelly and to achieve the speed of and it's to reduce the time. Okay, so this is called a parallelism. In a parallelized computer, what are the points we focused on performance wise? So first thing is degree of parallelism. So what is meant by degree of parallelism? It is nothing but how many number of processors are executing parallelly at a given unit time. If you take one unit time or one unit time period, at that time period, for each time period, how many number of processors are executing parallelly, or how many number, in other words we can define like this, in for a given time period, what the number of processors used the parallelism is called as a degree of parallelism. It is simply called as DOP. DOP is very important one. It's a basic thing before going to see the next things and all, next you measures and all. So DOP is nothing but it is a total number of processors involved in a parallelized execution. Okay, so if you plot the degree of parallelism value with the given period, you will get one chart, one bar chart, one curve. That function, that plotting of this your DOP with a function given time period is called as a parallelism profile. So parallelism profile is a plot of the DOP with a given time period, is called as parallelism profile. Okay, so if you DOP value will change. So if so there are some ideal cases are there. If DOP is equal to 1, that means degree of parallelism is equal to 1 means, in that case only one processor are executing parallelly, that is like a uniprocessor execution, that is not seems to be a parallel processing. One by one sequential equation, that is treated as sequential equation. If DOP is equal to n, where n number of processors are involved in parallel computer means, that means if the value of DOP is equal to exactly n means we achieved a high parallelism in that case. But that is not practically applicable. But when we can say when we achieve the high parallelism in n number of parallelized computer means when DOP is value equal to 1. Okay, when DOP value equal to 1, we achieved the high parallelism. When DOP is equal to 1, that is equivalent to sequential equation. Sequential execution. Sequential execution means it's like a uniprocessor execution. One by one the processor will start executing its processing. Okay, so this is the basic two ideal cases when you come across with a DOP. Once again I am repeating, DOP is equal to 1 means that is treated as a sequential execution of your programs, and when the DOP is equal to n, where n number of processes are involved, means where we achieved that high level of parallelism is achieved in that execution. Okay, so this is about degree of parallelism. Next, I already told that parallelism profile is a plot of DOP with your function time period. Okay, so what are the factors which affects the parallelism profiles means, first one is the algorithm structure, that is called as a design of your software, and program optimization, resource utilization, runtime conditions, and realistically limited by n number of available processors, memory and other non-processor resources. These are the important factor which affects the parallelism profiles. First one is algorithm structure. Obviously your algorithm should be adaptable by the parallelizing computers. It should adopt with the n number of processors, and it should have prioritized with n number of processors. And program optimization, your program should be optimized with your parallel execution. Resource should be utilized effectively. And runtime condition, your runtime, when you go for the runtime condition, you need to search the speed of factors. So what may be the speed of factor, and memory utilization, memory availability. So these are all the very important sensitive indicators of runtime conditions, sensitive indications when you are going to execute your program in the execution time, at the runtime time. Okay, so likewise you will be having more factors affecting the parallelism profiles, right? Then average parallelism is one of the term. It is defined by one equation where n is a homogeneous process, where n is defined as a homogeneous process, it's not a heterogeneous process, and m is the maximum parallelism in a profile. I told you, no, m is a maximum parallelism means n DOP is equal to n. Then computing capacity of a single processor is defined by the symbol, and DOP is equal to I minus n processes busy during an observation period. Okay, so DOP is equal to I minus the n number of processes busy during the, if we going for an observation time, at that time how many number of processes are busy. Okay, so that is called as DOP, it is equivalent to DOP. Then how we can measure the average parallelism means, we have one formula, W is equal to delta integral part of T1 to T2. T1 and T2 are the given time period, and DOP of T dt. Okay, so DOP of T dt, it is an integration formula. So when you apply the values of DOP and T time periods, you will be getting the work performed, total amount of work performed. Okay, so this is called as average parallelism, and we are now taken one example exercise, example plot, where we are comparing the parallelism profile with average parallelism. So when you see this graph, this x-axis denotes the time, and y-axis denotes the DOP, that means degree of parallelism. So when the time period, it is a time cycle, 2, 4, 8, 10, like that, it has cycle wise only that time is plotted. Then here if you see the degree of parallelism in each time slot, you will be getting one values. In here we have calculated the average parallelism, which is equal to, lies between 3 to 4 in the degree of parallelism. So what is the average parallelism value in this example is, it may be 3 point something, 3.8 or 3.9 something, it is between 3 to 4. Okay, so that is the average parallelism achieved in this case, in this example. Okay, then next one is, next measurement performance metric is like how we can compare the performance in a multi-mode computer. Before that we have measured all degree of parallelism and parallelism profile and all for a homogeneous processes. That means that processors are of the same type, but in a different way. That means if you are having n number of processors with m programs, but these processors are working in a multi-mode manner. That means if in the previous cases all n processors are homogeneous processors, but in this case all n processors are heterogeneous. Heterogeneous means it is a multi-type. How we can measure its performance means we have three different kinds of measurement points. One is arithmetic mean performance, second one is geometric mean performance, and third one is harmonic mean performance. Let us see one by one. Arithmetic mean performance. So this arithmetic mean performance is subscripted in RA. RA is called as arithmetic, and it is a summation of I to m. M is the total number of program size, and Ri divided by m. Okay, Ri divided by m. So this Ri, it is simple one. How we are progressing arithmetic progression and geometric progression we are seeing. No, the same concept is applied here. Here summation of I equal to 1 to m, Ri divided by m is the average arithmetic mean performance value. In your right side you can able to see the geometric performance values equation. Here Rg is denoted. G is the meaning for geometric mean performance, and it is divided. It is calculated as a pi symbol. I equal to 1 to m, Ri 1 divided by, that means it is 1 divided by m. That means Ri to the root Ri 1 divided by m is the equation for this geometric equation mean performance. Similarly, harmonic mean performance is also calculated. Here the formula for harmonic mean performance is equal to Ta equal to 1 divided by Ri, mean execution per instruction for a program I. Okay, so these are all the three different mean performance metrics we have are coming under the heterogeneous types of processes. So in the previous one is the homogeneous process, and these three performance metrics are coming under heterogeneous processes. That is nothing but n number of processors are working for a m size program size in a multi-mode operation. Right? I hope you understand the concept. I'll catch you in the next video about next topic. Thank you.